Okay, inverse function. Today we'll discuss inverse function. So what is that inverse function? So let f is a function from a to b. Okay, okay, this is bijection. Okay, okay, f is a bijection from a to b. F is a function which is bijection. Then f inverse is also a function from b to a. Is also is also is also bijection. Abhinav, why you are writing? Okay, now f is a function from a to b. Let's say it is bijection. Then f inverse is also a function. So generally, so here let's take an example. Generally, let's say this is a function from a to b. Okay, this is a function only. Okay, so a, b, c, d. Okay, this let's connect like this. Now this is a function. F is a function from a to b here. But f inverse is what? F inverse is f already we discussed. F inverse is a relation from a to b, b to a. F inverse is relation from b to a, c, d. F inverse, if you write na this 1 2 3, a to 2 like this. This is in b to 1 and c to 3. This F inverse is a relation from b to a, but it may not be function. You got this point? If you see here, uh, this is a function. F is a function from a to b because here every element has only one image. 1 has only one image, 2 has only one image, 3 has only one image. Therefore f is a function from a to b. But f inverse is not a function from b to a. Why? Because what is the condition here? F has to be bijection so that f inverse becomes a function. If f is a bijection, then f inverse becomes a function. Now here in this case, this is a function, but this is not a function. F inverse is simply, it is a relation. It's not a function. Why it is not a, why it is not a function? You know the reason. Okay, now this is f is a function from a to b, which is not it is one, but it is not onto. It's not onto. Therefore, it is not bijective function. Therefore, f inverse is not a function. F inverse exists for everything. F inverse exists, but thing is that f inverse is function or not is the question. Now, f inverse is simply, it is a relation and not a function, but not function, but not function. Yeah. So now let's go to second example. Let's go to second example. What is second example? Let's go to second example that let's take now here one more. A, this is B, is 1, 2, 3, 4. Here A, B, C, D. If at all a function is both 1, 1 and onto, that is bijection, then number of elements in A must be equal to number of elements in B. Okay, here four elements mean here four elements must be there because it's both 1 1 and onto. Now 2 to D, 3 to A, 4 to C. Now f is a function. This is bijection. F is a function which is bijection, that is both 1 1 and onto. How do we know it is 1 1? Different elements, four different elements have different images. No two elements have same image. Different elements have different image. Therefore, it is 1 1. Why it's onto? Because in set B, every element has pre-image. That means codomain is B, range is also total B. So therefore, it is bijection. Now, F inverse you find. What is F inverse if you find here? This F inverse if you find, this is A, B, C, D. So this F inverse is B to A. Okay. So this is 1, 2, 3, 4. Now A image is what? A image becomes A to 3. And then B to B to 1, C to 4, D to 2, D to 2, like this. So now automatically this F inverse, I write F inverse. F inverse is simply, it is a function. Not only its function, but it is bijection also, both 1 1 and onto also. So therefore, what we learned here is if f is a function from a to b, then f inverse exist always, but this F inverse may not be function. But if at all F inverse has to be function, F is a function from A to B, F inverse function to exist. What is the condition? F has to be bijection, both 1, 1 and onto. Then F inverse exists. F inverse means inverse function exists from B to A, and that also becomes bijection. Now I showed here F is a function from A to B. F inverse existed, but this is not a function because every element has no image. D has no image. Every element should have image for function. F inverse is not a function because D has no image. Therefore, F inverse is relation but not function. So, but whereas second example we have taken where F is a function from A to B, which is both 1, 1 and onto bijection, then F inverse, if we find, it is a function from B to A. So that is also bijection. Therefore, conclusion is if F is a function from A to B, which is bijection, then F inverse exists. That is a F inverse also a function from B to A. Inverse function exists. That is also becomes bijection. That is a thing here. I gave you example for inverse function, which is finite inverse function. Now let's take another example. What is that? Let F maps R to R defined by 1, defined by f of x equal to 3x plus 2. Okay, 2. This is also from R to R defined by f of x equal to x square. Now we'll do what you should find. Find inverse of the function. Find inverse function. For this function, you have to find inverse function if it exists. If it exists. Okay. So now what you should do in this, you have to find inverse function means, first of all, you have to check whether it is 1, 1 or not. So for first question, find its inverse if exists. If exists is a question. So now first thing is f maps R to R defined by f of x equal to 3x plus 2. So first 1, 1 or not, you have to check whether it is 1, 1 or not. Just by seeing only you can understand. So different elements, let us take x1, x2 from R domain, such that how do you take such that f of x1 equal to f of x2. Then what will happen? 3x1 plus 2 equal to 3x2 plus 2. Then 2 you can cut off now. Then x1 this 3 also you can cut off. 3x1 equal to 3x2 you get, then x1 equal to x2. That means what? If you take here not equal, this also not equal, this also not equal, this also not equal. Different elements have different images. We showed 1, 1. Onto or not, how do you check? Already we discussed now. Let f of x equal to y. Okay, that means image of x is y. That means pre-image of y is x. So what is f of x? 3x plus 2 equal to y. So what is here x value? Y minus 2 by 3. This is what is pre-image. This is what is pre-image. So that means if y is a real number, see, y you have to take real number. Y is a real number. If you take any real number, that pre-image is y minus 2 by 3 also real. So what you can say, for every y belongs to codomain, codomain, there exists pre-image. What is that pre-image? Pre-image x equal to y minus 2 by 3. For y, pre-image is y minus 3 by 2. Sorry, y minus 2 by 3 is a pre-image exists. Therefore, it is onto. So, onto. Therefore, what is the conclusion then? Therefore, f is bijective function. Bijective function or bijection. Then that implies what? F inverse is also bijective function. Okay, therefore, what is f inverse x? I told you f of x equal to y, na? Then x becomes f inverse y. So I gave this one, na? F of x equal to y. X becomes f inverse y. X becomes f inverse y. So f inverse y equal to then what? F inverse y equal to what? X. What is x? X equal to y minus 3 by 2. Y minus 3 by 2. Simply, what does it mean? F inverse is also function from B to A. B to A means R to R. Okay, you can see here B to A. B to A means what? R to R. This is A, this is B. A to B means R to R. B to A also R to R. So defined as f inverse of y I wrote here, f inverse of y. But if you write x, this also becomes x. Simple it is. Why I wrote x here? Here y is there now. Why we should write x? In the place of y, if you put 2, in the place of y, if you put 2, 2 minus 3 by 2, get if you get 5. So y is here real number. You can put any real number. Here also 1, 2, 3, 4, 5, anything you put. So if you put x also, same thing. X also you take from real numbers. So now therefore, like this, you have to find out. Very, very simple method. So already we know how to find out pre-image, this one already we learned how to find out pre-image. So that pre-image only we are writing like this, because the pre-image only we are writing like this. So this is f inverse and this is r, this is r. F inverse only we are writing. If you take y here, what you get here? Y minus 3 by 2. Y minus 3 by 2. Previous, no, this one I wrote. This is f, no.
Sir,
Wait. This is f. Sorry, this is f, na?
sir, once more repeat, sir.
Okay. All right. So y minus 2 by 3. Y minus 2 by 3. So already we know this. If you take y, its pre-image is y minus 2 by 3. So, but here, what I'm the f inverse, if I take f inverse, what will happen? If I take f inverse, this is b and this is a. And this is y here, then y minus 2 by 3 is here. If you take here x in the place of x, if you y, if you take x, this becomes what? X minus 2 by 3. So f inverse is a function from b to a. That b is what? R to R. Okay, very simple. You have to find out the pre-image. Pre-image becomes what? Pre-image becomes image for pre-image becomes C. This pre-image is there. This pre-image only, this pre-image becomes what? Image for inverse function. Now like this, now reverse, we are reversing. So already I told, no, here. So now here, what is here? Yeah, here. Image of 1 is B. But if you reverse it, what we call inverse image, we say. So inverse image of B is 1. Inverse image of B is 1. Inverse image of A is 3. Inverse image of C is 4. Inverse image of D is 2. But here, what will happen? F inverse of A. Here, what we write is f of 1 equal to B. But here, what we write? Reverse, na? F inverse of inverse image, na? F inverse of B. F inverse of B equal to 1. See, this is a relation here. Hope you got it, right? So now if you take that side b equal to f of 1 only, na, that only you get here. So therefore, if 1 is image of B, 1 is pre-image of B or inverse image of B, you can write f inverse of B is 1. So like that only all. So here all the images becomes what? Images becomes pre-images when you reverse it. Very simple idea. All the images becomes what? Inverse images. So that's why we wrote here. That's why here what we wrote, inverse image we wrote. See, now this is a pre-image or inverse image becomes what? Image. So simply you need to find out a pre-image or inverse image, you need to find out for the inverse function. So that's what is the thing here. Wait a minute. X, so here f inverse of y equal to y minus 2 by 3. You understand? So in the y means what here? Y means simply real number. That means what? F inverse of 1 is what? 1 minus 2 by 3. F inverse of 3 is what? 3 minus, or f inverse of 2 is what? 2 minus 2 by 3. Yes or no? So that means in the place of y, you have to put real number. Here, what we can write in the place of, we can write here, y also you can write here. X also you can write. You can write Z also you can write here. Why? Because here Z is not a number. Z is not a constant number. Z is a real number here. So here also again you can put 1, 2, 3. You get the same thing. You will not get any difference. So but finally we write in terms of X, because it's asking us to find out inverse function. We write in terms of X only. But you can write in terms of Y. There is no problem. If you want to put it here, only Y. For example, you want to put this one only Y. This one you want to put y, you can put in one y only, no problem. Y minus 2 by 3. But where, what is y here? Y belongs to R, domain. Yes or no? Y we have to take from what? Domain. then f inverse of y is image is this. No problem. But generally we write in terms of x only. Good question. Next, any other question? Okay, then I'm going to next question, then you can understand. So here, this f is a function from R to R defined as f of x equal to x square. So it's not 1, 1. Why? Because -1 and +1. -1 and +1 will have the same image here. So here, f of x1 is plus or minus x2 you get. So -1 and +1 will have same image, that is 1. So therefore, it is not 1, 1. And also not onto, because for every element there should be preimage. But -1 preimage is root of -1, that is not there in real numbers. Similarly, root of -2 also not there in real numbers. Therefore, inverse function doesn't exist. Inverse exists, but inverse becomes only relation, not the function. Okay, that's what I told. So